I am the political science librarian at the University of Florida, and I'm going to talk about statistical significance versus practical significance in the information science and library world. All right. The problem is that academic libraries face increased pressure to assess and quantify their impact on students' educational outcomes. Student outcomes such as retention, attainment, so graduation rates, success, which includes career placement, future earnings, whether they go to graduate school, their achievement, GPA, and test scores, and they tend to collect more detailed types of transactional and behavior student data, libraries do. Library studies like this often require detailed and personally identifiable records that can be linked to other informational sources. The correlation between libraries and student outcomes are hard to make because there are many other causes besides the library intervention that can be the result of the data. Thus, often these studies will show statistical significance and it will not be because of library intervention. However, libraries love to use these statistics for practical use so that they can increase their funding and justify their value. Unfortunately, without quantitative information these days, you have a hard time dictating your worth. Unfortunately, the side effects of the data obtained from individual students is usually far more valuable to institutions when aggregated than it is to the subjects themselves. The parties likely to use the library benefits or the library data analysis are not only universities, but also third-party educational service providers, including for-profit organizations whose primary responsibility is to their shareholders rather than their students. A case would be for vendors in the library world, for example. All right, so the study parameters. This study started with 44 possibilities and ended up with 17 grade-related studies and 6 retention-related studies. The authors proceeded with only the studies that examined the relationship between library use and instruction and students' grade outcomes. In order to maximize the number of studies that could be included, they decided to group all types of library instruction and all types of library usage together, creating 2 meta-analysis groups, instruction by GPA and library use by GPA. The effect size chosen for this meta-analysis is the correlation coefficient, or R. The statistic was utilized instead of the more common Cohen's because the majority of the studies used in the analysis utilized correlation and regression calculations, and therefore a Pearson's R statistic was already present. In the case of these studies, an R value of 0 to 0.2 should be interpreted as no effect, 0.2 to 0.4 a small effect, and 0.5 to 0.7 a medium effect, and above 0.7 a large effect. The issues. So the meta-analysis contains several limitations due to the nature of the underlying studies that provided the data. First example would be precise definitions of both dependent and independent variables were often not entirely consistent between studies. For example, one examined the impact of one-shot library instruction on cumulative GPA, whereas another investigated the impact of multiple types of instruction on first-year GPA. Because the designs included in the study potentially sampling bias is extremely difficult to avoid and might skew the results. For example, many studies use counts based on easy proxy logs as a library uses to measure, which may be systematically biased depending on how those logs are set up, as well as e-usage and physical usage are not necessarily directly comparable, even though they are treated as the same in this analysis. So this metadata analysis had 2 main goals: to evaluate the overall impact of academic library services on measures of student success, and to use the outcomes of that analysis to examine the ethical implications of library learning analytics research. Rather than stopping at statistically significant findings, which is unfortunately often the case with library impact studies, the authors sought to measure the overall effect indicated by these studies. The meta-analysis presented here indicate that there is no or a very small effect of library use or instruction on student GPA outcomes. While the data provided by the bulk of library analytics studies prevented evaluating other additional outcome variables, such as retention and attainment, these findings nevertheless have important ethical implications for all types of personal data-intensive library learning analytics research. Perhaps due to the librarian's enthusiasm for their work, there is often a tendency within these studies to over-interpret results and overstate the library's contribution to student outcomes, practical significance, even though there is generally a small statistical significance. Large data sets are more likely to produce statistically significant results when comparing means and distributions between populations, as well as false correlations between variables, especially complex real-world observations. In fact, to take the findings of the studies included in this meta-analysis at their statistical face value, they do at least as much, if not more, to support an argument that all libraries are contributing very little to overall student success, while administrators and librarians argue statistical relevance or practical significance. There are obviously many other factors and confounding variables that impact student success that lie well beyond the library. For this reason, focusing only on the impact of the library on student outcomes artificially inflates the contribution for better or for worse, an approach that presents both methodological and ethical problems, such as students being unaware that this data is being collected. The two meta-analyses were completed using comprehensive meta-analysis software, and a random effects model was used for both groupings. A random effects model assumes that there is no theoretical true effect shared by all of the studies analyzed, and is therefore more appropriate in this analysis than a fixed effects model that assumes that the factors that influence the effect size are the same in every study. The library used by GPA analysis included 10 studies which examined the impact of different types of library use on grade point average. The null hypothesis that there is no effect across these studies was rejected, and there was a small effect. Again, the precision of this analysis is relatively low, as indicated by a wide confidence interval around the effect size, which ranged from no effect to a small effect. Overall, the results of the studies sometimes reported significant results, but did not report basic descriptive statistics required to evaluate the quality of the study, such as mean, standard deviations, and sample sizes. Others inappropriately described the p-values with adjectives like massive significance, which is an incorrect characterization since as p-values indicate probability, they do not have size values attached to them. These types of incorrect descriptions contribute to the practical significance and overinterpretation of the results, as well as slippage between reporting correlation as implied causation.